We're going to move on to the blue parts next, but for this next bit, we need to step into the character blueprint. So we'll compile and save that. What we're going to do is build a scanner, which is basically going to count the number of actors in a radius that we've specified around the player. The actor types can be anything that we want them to be. It could be zombies, diamonds, asteroids, submarines, love, anything you like. It doesn't matter what character blueprint you're using. I'm using the first person one, but you can build this in the default third person, or you could even add it to a vehicle. So we're going to create a new custom event called find local actors. We'll then get the call function of that and plug it into the event tick, find local actors. Next, we'll create a new custom event called find closest actor, and we'll leave this one for the time being. Now we'll create two new arrays, one of which is a float array and the other is an actor array. I've called mine list of distances and list of actors. From the find local actors node, we're going to add two clear nodes and hook our two new arrays up to them. Next, we'll create two new variables, one which is an actor variable called closest actor, and another which is a float variable called closest actor distance. And we'll hook this up after the clear arrays, and we'll just leave the inputs blank for those, which effectively sets them back to nothing. Then we're going to add the call function to our other custom event, find closest actor. And that's this bit done. From our closest actor node, we're going to add a sphere overlap actors node. We're going to get the player character, and from that get actor location, plug that into the sphere position input. Promote the sphere radius input to a variable so we can edit that and make that editable, so we can change that in the main view in the editor. I've set mine to 100,000, which is overkill, but you can adjust that depending on what you need. From the object types, we need to get the make array node, and from there for this, because we're looking for enemy zombies which are controlled, we want the pawn item in that drop down list. But it's this point where you can change things. If you wanted this to be treasure, for example, you could use static or dynamic, and then you could filter further. So I've filtered here to the specific blueprint, this blueprint AI master, which controls the zombies. The actors to ignore bit, I've taken a reference from the player character, made another array and plugged that in there, and that means that we don't inadvertently count the player character as one of our pawns. From the return valid output of our sphere overlap node, we're going to add a branch node and hook that execution pulse up as well. Then we'll create a new variable by right-clicking on out actors, and we'll promote that one. And I've called this list of actors, and we'll set that from the true output of the branch node. And then from the false output of the branch node, we're going to add a new variable, which is number of actors as an integer. So this means that if no actors are detected, then we're going to set this value to 0, and we'll use that later on in the Quartz blueprint and also in our HUD. After we've set the list of actors, we're then going to add a for each loop plugged into these two outputs. And then from the loop body, we're going to drag in a reference to our list of distances array, and we'll have an add node. From the array element, get distance 2, and the return value will go into the input of that add node, get player character. So this node is getting the distance between all of our actors in this list and the player character. Then next, from the completed output pin of the for each loop node, we'll set the closest actor distance. What we're doing here is we're getting that list of distances we've created, we're getting the minimum value, the closest distance, and then we are routing that minimum value into the closest actor distance and setting that. The index of that min value we're putting in here, and then we are finding that actor in the list of actors and setting that to the closest actor. Next, we're getting the list of actors as a length, and we are setting that as the number of actors. This last bit here is just for debugging. This shows the closest actor, how far away they are, and it also draws a line between the actor and the character. You can copy this bit down if you like. While we're in the character blueprint, we'll create some nodes for our motion tracker. If we go to Edit, Project Settings, and Input, we'll add a new action mapping, and I've called this Motion Tracker, which I've assigned to the letter T. Then, in our character blueprint, we'll get a reference to that motion tracker, right clicking and motion tracker, and there under action events, there it is. From there, the flip-flop node, A will go to set the tracker active as true and B to false. So this is a new Boolean variable, and by default it is false. So this lets us activate and deactivate the motion tracker as we want, and we'll need that information for the Quartz motion tracker blueprint later on. Now we need to tell our Quartz blueprint what to do when there are no enemies left. We're going to repopulate our stored sound arrays. We'll reset the volume of the assets, of the ones that we faded out. We'll reset our Quartz clock. We'll play the opposite array to the one that was in play, and we'll increase the round counter, which we're using for some text in the HUD. So first, we'll create a custom event, which I've called on0enemies, and from it we'll add a branch node. In the condition, we'll get a reference to our character blueprint, the number of actors. If that equals 0, we'll plug that into the branch. Then we want a do once node with the true part of the branch node going into the main exec and the false going into the reset. And this will be start closed. If we leave this unticked, then our music begins to play twice. Once through the Quartz setup, which we made earlier, and again through this path because the enemies haven't spawned in yet. So you might need to tweak this a little bit to fit your project, but that should work for most cases, I think. Then we'll add another branch node with virtually the same check, which checking how many number of actors there are, but this time we want to see if it equals 7, which in my setup is the maximum number that I've set in the spawn blueprint. Again, you'll need to tweak that for your own project, and you might want that as a promoted variable so you can edit that from outside the blueprint as well. So this segment is checking to see if we have actors before it allows the execution pulse to run forward. To the false output, I'm adding a delay of 0.1. It doesn't have to be that quick. At this point in time, once the last zombie has been killed, all of the music has been faded out. So we don't need this to be synchronous at all with the Quartz clock. So that delay could be longer, but again, tweak that. To the true output, we're going to add our set sounds function. And next, we're going to create a new custom event called reset volumes. We'll come back to deal with that bit in a moment. This is over here. We'll come back to that later on. For now, we just want the call function added into our step here. Next, we want to drag in a reference to our Quartz clock, and then from there we want to reset the transport. By using the reset transport node, we are resetting the music clock back to the first bar. Then we'll add a switch node, switch on end node, with our current bank playing plugged into the selection input of this. Then you can see that we have the same play quantized sections as we had before, only if the current bank is 1, then we are going to play the sounds 2, and if the current bank playing was 2, we're going to play sound 1. Quantization boundaries for both bar, multiplier, and transport relative. So that's going to start at the very beginning of the clock. So we have our synchronization again. When it comes to loop the music once more, it'll be doing that on that 24-25 bar point. Then we do the same again. We route both of these into a duplicate of that, which is the play quantized for our stored one-off sound. So the death scream or the Aztec death whistle that I have in my setup here. Then we're going to add a Boolean, a new variable, which by default will be unticked, but here we're going to set it to true. Then we'll add a new integer variable, which is round number. We'll take round number, add 1, and then update the value for round number here. And lastly, we've got another print text debug section, which is just to confirm that a new round has been begun and all the sounds have been loaded in successfully. Lastly, we need to get a reference from this, and we're going to plug this into the event tick. So back in our event tick, we're going to add the on0enemies call function here. And that is our blue shift done.
You think there's a cold beer for us at the end of all this?
Next, we'll move on to the orange boxes. So we've already made our reset volumes custom event. We'll do that bit first. So we are going to pull in references to our stored sounds arrays 1 and 2, and we are going to set the volume multipliers for both of those to 1. So we're resetting the volumes for everything that's in those arrays, and that is the easy bit done. This is a little bit more spaghetti-like. This is the most efficient way that I could get this to work. If there is a more efficient way, please let me know in the comments. So first of all, I'm going to create a new event called manage fades, and we'll add that call function into our event tick as well. From this new event, we are going to add a branch node. Into that, an equals sign. And again, we'll get that reference to the number of actors from our character blueprint. And we'll take our sound set array, the sound base array, get the length of that and plug that into the lower pin. If it's true, we don't need to do anything. We have the right number of tracks to match the number of zombies in the level. If it's false, then we are telling the system that we need to make some changes. We have too many tracks. First, we'll add a sequence node from that false output of the branch node. And from the first output of the sequence node, we'll add a gate node with that as its enter. From the gate node, we are going to add a do once node. And now we'll scroll back a little bit. From the second output pin of the sequence node, we're going to add another branch node. And the condition here is to check what the current beat is. Is it equal to 1? If it is, we're going to use another do once node with the completed output going to the open input of the gate node. If it's false, then we are going to close the gate. Next, we'll add a new custom event called reset fades, and we'll add another sequence node to that. The first output connects to the reset of our do once node before the gate, and the second output connects to the reset of the do once node after the gate. If we are fading out a track over more than one bar, this do once node before the gate prevents the fade out action from repeating before it's been finished. And we are setting that gate to start closed initially. So we've killed a zombie and our numbers don't match over here. So we're getting ready to open up the gate, and we're waiting for the quartz clock to hit beat 1. When it does, we are opening up that gate, and as soon as the beat moves to 2, we are closing the gate. Next, we'll add a timeline node and connect that to the output pin of the do once node into the play from start input. In the timeline, we want a float track, and we want 2 keys in here. One with a time of 0 and a value of 1, and the other with a time of 1 and a value of 0. This is our fade out. What we'll do is we'll scale this using a function we'll create in a moment. From the update output pin of our timeline node, we're going to add another sequence node. So from that sequence node, we're basically going to create 2 sets of the same thing. So you can see that these are the same. The only difference being that we have stored sounds 1 and stored sounds 2 here. Everything else is identical. For this top one, we're adding a for each loop node, and the array input is stored sounds 1. The array index will go to a greater than integer node, with the bottom input being another reference to the number of actors from our character blueprint, -1, and that is plugged into a branch node, which is connected to the loop body of our for each node. Our array element, we're actually going to route this into 2 places. We'll come out to the second branch over here in a moment, but for the first part, we're going to route that into a set volume multiplier node, because that's the target that we are going to apply that volume multiplier to. And we're going to take the true output of the branch node and hook that into the set multiplier volume node. And we are going to take the float output of our timeline node and hook that up to the new volume multiplier input of the set volume multiplier node. Once you have that section in, we are then going to duplicate that down here, but this time we will swap out sounds 1 for sounds 2. This section compares the length of the stored sounds array with the number of actors. If we have more sounds than actors, this will fade out each item in the array that exceeds the number of actors. So if we have 8 tracks playing, and we manage to kill 7 actors before the quartz clock returns to beat 1 again, then it would simultaneously fade out 7 tracks. This bit took quite a lot of work to get right, and despite that, like I say, it still looks pretty messy. I wanted us to be able to fade out several tracks at the same time, based on the number of actors that were still active in the game. With this setup, we'll be fading out multiple tracks at the same time, or they will have finished fading out by the same point. But I'm not sure it's the most efficient way to set out the nodes. If there is a better way to do this, please leave a comment below. So now let's look at this gate node. So for both sections, the outputs of the set volume multiplier nodes go into the open input of the gate node. The false output of both branches goes into the close input of the gate node, and the enter input is coming from yet another sequence node. And this time it's attached to the timeline's finished output node. So we have a sequence node here with the first pin running along into enter, and the second is going to our reset fades function. This one here that we made earlier. And we want this gate to start closed. Basically, we don't want this to be opened up until all the criteria running through our branches is met. This last little section is, again, another bit that took a little while and quite a lot of tinkering to get right. Bizarre, given how simple it actually looks in the end. This is where the sounds are removed from their corresponding arrays, and this is important because if the player kills a zombie, but then doesn't kill the rest of the zombies before we reach bar 24 and flip-flop into our alternate array, when the alternate array does load up, it brings back all of the sounds that we'd faded out, and then it proceeds to fade them out. Useless. So this little bit of code here basically updates both of the arrays at the same time, so that any items that are removed from array 1 or 2 are removed from the opposing array at the same time. Even if they're not active in the stream, they're just removed from the array. Because this is attached to the finished output of our timeline node, once the sounds are being faded out, they are removed from both arrays. So these two clear array nodes that we added to our set sounds function earlier will clear out anything that hasn't been removed at this point prior to a new round starting. So that should keep everything neat and clean. And now we only have one step left in this Quartz blueprint. So we've done our main orange box down here. We've done a blue, we've done a pink. We've added our blue here, our orange here, and our pink here. We have another orange function here. This is the set fade duration node. And I mentioned earlier that we were going to take the timeline and we are going to adjust it, we're going to scale it, and we're going to do that in here. So we did a new function called set fade duration, and for this one we're going to do a little maths. If we go to our class defaults and we have a look at the fade out in bars, this is how many bars we should fade out over once an enemy has been killed, with a default of 2 bars. So let's tuck that away and we'll create a new float variable called fade out in bars. We'll put a default of 2 in that. In our new function, we will get a reference to the timeline node. So let's right click and get timeline, and from that we want our set play rate node. Oh, we're also going to make the fade out in bars editable so we can access it from the main window. And this is our calculation to convert musical time, our beats per minute, into seconds, which is the measurement of time that the timeline operates in. So we're going to take our beats per minute value, we're going to take a divide by node, 60 divided by that beats per minute. We are then multiplying that by the beats per bar integer. We are then multiplying that by the fade out in bars value, and then we're taking another float divide by float node, 1 divided by the result from this calculation here. And that gets us our rate. So back in our main event graph, we are going to add this to the event begin play node, to that sequence of events. And that is everything for this blueprint. All sorted. We can compile and save that. So let's test this out. Now I already have an entry in here. I'm going to remove that so we can do the setup together, like good friends do. So back in our content browser, we are going to find where we put the blueprint. And I've made a child of this. You don't necessarily need to do that, but I've made a child of this blueprint. So what we can do, because it's a child of the blueprint, this is a little trick that I learned from watching a video by Dan Reynolds. So this is our blueprint where we've done all of that work. Control B will take us to it. If we right click on that and create a child blueprint class, then we load that up. We close it again. You open it once more. Now we have all of our entries in here. We don't need to mess around with the code. We have everything that we need in here, so we can set this child blueprint and do everything that we want to do with it, and then drop it into our level. So if I took all of my audio from, say, let's do an alternative version of the music. I can plug this into my sound set array, compile and save that. Now I can drag this in here, and here we can set our volume if we want it to be changed. We can set our fade out value. We can add a one-shot sound in, so let's do that as well. So let's turn this up a bit. So that's our one-shot sound. We'll add that in as well. Now, unfortunately, because the tracks I'm using contain barely edited versions of files that I've bought, I won't be able to share them. But I have created my own synths from free VSTs. You can use those. I've put those in a link to download those in the description below. And we'll use those now, so you can see how they'll function and operate in the system. Now, there are only 4 tracks there. We have 7 enemies, so what I'm also going to do is I will add in 3 of the drums as well. So we'll just drop those into the sound array. We've got to put on that green space there when it highlights itself. We can add those in. The free music here is the same length. All the settings for the music are the same. It is 24 bars long, 120 beats per minute, 4/4 time signature. And let's put our debug on so we can see our current bar, beat and mod value. It'll also show us how close the nearest zombie is and what bank it is that we are drawing from, what sound array is currently active. What we'll also do is we will add the line au.debug.soundcues1. We'll put that on. That will show us the number of active sounds, and it'll give us a list of those active sounds as well. As I move around the level, we'll be able to see those values fading out and sounds being removed as they're pulled from the array. Press play, make that a big screen. And up in the top left then, we can see the clock name here. We've got our mod value increasing. That's the one that'll cycle every 24 beats, 24 bars. We've got a bar number rising, our beats rising, 2, 3, 4, 1, 2, 3, 4. We can see the distance to the nearest AI is changing as that moves around, and we can see that we've currently loaded bank 1, our sound array set 1. So now, if we go to the bottom here, we've got au.debug.soundcues, and now we can see all 7 tracks that are loaded in. And if we listen, there we are. We've got our second bank loaded up. We've tripped over here, next section loaded. We're now bank 2. Those other sounds will disappear as their reverb fades, and now we're back to our original 8 tracks. So let's go through and remove these zombies from our map. I'm not the best first-person shooter, but if you have a look, you can see that and hear that we are losing audio. Is it here? They can't detect me. So we're now down to 3 tracks. If we shoot one of these off, you can see that the fade out is working there, and if we're back to array 1, if we kill off the zombie, everything's faded out. And there they are back. Round 2. That's all for this video. In the next video, we'll create a motion tracker using the system we've developed to detect nearby enemies, and we'll run the whole thing through Quartz. Thanks for watching.